Hello. So now we will learn one of the classical TCP improvement called as transmission or timeout freezing. So previously we have seen indirect TCP, snooping TCP, mobile TCP, and fast retransmit or fast recovery techniques. And now we will see what is a retransmission or timeout freezing. Whenever mobile host is disconnected, then this disconnected can be for a long time. For example, suppose somebody is driving the car and mobile device is with him or her in the car, and car is going through the tunnel, right? In that case, and the length of tunnel may be some 2 to 3 kilometer long, and in that case the disconnection of the mobile node may be very longer, and in such a situation no packet exchange is possible until and unless the mobile node has again reconnected to the network, right? And in such a longer disconnections, TCP disconnects after a timeout completely. It means after some predefined amount of time, TCP connection is disconnected permanently after some long time. Okay, so to cope up with this problem, one technique is used that is called as the TCP freezing. And what is that technique? So in MAC layer, MAC means medium access control layer, which is the below network layer. It means that it is on the data link layer. So MAC layer is often capable to detect the interruption in advance. It means if disconnection is to be occur in near future, it can be detected by the MAC layer before the actual disconnection happens. And the MAC layer can inform this information to the TCP layer or transport layer about the such upcoming loss of the connection, and it can also specify what is the reason behind the disconnection. Then upon receiving such information from the MAC layer, TCP can stop the sending, but this sending does not assume that a congested link, right? Whether even though TCP stops sending the packets, in this case TCP does not assume that there is a congestion in the network, but this sending is suspended due to the information sent by the MAC layer. Okay, and again, as soon as MAC layer detects the connectivity again, then it can send such information to the TCP so that TCP can resume the operation. So it is the freezing technique. And advantages of this freezing technique is that this technique is independent of any other TCP mechanism. It means such as the acknowledgements or sequence numbers. It means the freezing technique does not use the acknowledgements or the sequence number which are there in the traditional TCP, and it can be used together with the encrypted data as well. This is the second advantage of the transmission or timeout freezing. Then again it has some disadvantage as well. So first disadvantage is that TCP on mobile host as well as correspondent host has to be changed. Until and unless we make some changes in TCP on both sides of the nodes, it means correspondent node as well as the mobile node, then only this technique can be functionable. The mechanism depends on the MAC layer, right? So for proper or successful operation, this transmission or timeout freezing mechanism is totally dependent on the MAC layer. So these were the disadvantages of the transmission and timeout freezing. This video is in continuation with the classical TCP improvements, and now we will learn selective retransmission techniques which is used for classical TCP improvements. Okay. Acknowledgement mechanism which is used by TCP protocol in order to make a reliable delivery. That acknowledgement mechanism has some drawback, and that drawback is TCP acknowledgements these acknowledgements are often cumulative. Cumulative means we will see in detail what is cumulative. For example, suppose there is nth acknowledgement. Nth acknowledgement means any number. So this nth acknowledgement acknowledges all the packets in correct sequence from the starting point up to that nth packet. It is called as the cumulative acknowledgement. So with example you will see here. See here at sender and receivers are there. This is packet first packet which the sender will send to this receiver. Okay, this packet is transmitted, and in response to that packet, receiver now sends back its acknowledgement. This is the acknowledgement 1. So acknowledgement 1 represents that this acknowledgement is for the packet number 1 which is received by the receiver right now. Similarly, when the sender sends the second packet toward the receiver, now in response to this second packet, receiver now has to send two acknowledgement 1 and acknowledgement 2. So one for packet 1 and 2 for packet 2. Okay, it represents that till now receiver has received two packets from 1 and 2. Similarly, suppose this is third packet sent by the sender to receiver. Now receiver need to send three acknowledgements, 1, 2 and 3. So these type of acknowledgements are called as the cumulative acknowledgements. Means as the number of packets increases, then number of acknowledgement from starting point to the up to that particular nth packet are increased in number. That is called as the cumulative acknowledgements. And TCP protocol or TCP acknowledgements are often the cumulative in nature. What is this drawback? Now suppose if single packet is lost, then sender has to retransmit everything from the starting packet up to the lost packet. Okay, in reverse direction. Or suppose now this is the fourth packet, the sender want to send to the receiver, but unfortunately due to some transmission errors, this packet is not delivered to the receiver. Okay, now in this case receiver doesn't give any acknowledgement to the sender. Okay, so here in this case, now sender need to retransmit all the packets from the first packet up to the fourth packet, which is lost one, which is lost somewhere between the sender and receiver. So sender need to transmit all the packet from first packet up to the fourth packet. Okay, so this is the drawback of the TCP acknowledgement. And to overcome the problem of TCP acknowledgement, one technique is used that is called as the selective retransmissions. In selective retransmissions, a receiver can acknowledge a single packet only, and there is no need to acknowledge all the packets from starting up to that particular nth packet. Okay, and due to this, the sender can now determine precisely which packet it has to be transmit, and then it retransmit that lost packet, only single packet. Right. And advantages of this technique is it lower the bandwidth requirements since there are since the number of acknowledgement are less. That's why during retransmission the sender need to retransmit only that particular lost packet, then it requires the lower bandwidth clearly. That's why lower bandwidth advantage of selective retransmission is that it requires the less bandwidth. Then it has a much higher efficiency since bandwidth requirement is minimum, and it has the it provides us the higher efficiency. Then this technique have some disadvantages as well. Disadvantage is more complex software in a receiver side. Okay, so a receiver node needs the more complex software as compared to the other enhancement techniques. And another disadvantage is that more buffer is needed at the receiver side since number of acknowledgements are less. Then for proper retransmission purpose, if in case of the packets are lost, then more buffer are needed at the receiver in order to save the packets which are in transit. So this was all about selective retransmission enhancement of the TCP protocol. Then next topic is next improvement is the transaction oriented TCP. Till now we have seen all these enhancement, and this is last one, that is called as the transaction oriented TCP, right? So TCP has three phases. First one is this connection setup, then data transmission and connection release. Okay, so whenever a sender that uses TCP, that sender cannot transmit data immediately. Before that, the sender need to initiate or set up the connection, and after setting up the connection, then actual data is transmitted, and when transmission is over, then that connection is released. It means there are three pages: setup, transmission, data transmission, and connection release. Suppose these are the senders and receiver. Okay, so first of all, sender sends TCP sync to the receiver, and try to understand each request needs one packet in order to send the request to the receiver or vice versa. So first of all, for connection establishment, sender sends TCP sync packet to the receiver, and in response to that, receiver sent back to the sender a request that is called as TCP sync acknowledgement. And upon receiving this request, the sender again sends TCP acknowledgement. So these three requests needs three single packets. Okay, and the three requests forms the connection setup. After setting up the connection, then actual data is transmitted. Suppose this is packet number 1, and which the sender want to transmit to the receiver. Okay, so the data is transmitted. It is the data transmission phase. Once the data is received at the receiver, then connection should be released. For that, again three requests are repeated, which are the first one. So TCP sync acknowledgement, and TCP acknowledgement. This is called as the connection release phase. Okay, so these are three phases of the TCP protocol. But in this three phase connection, TCP connection, it requires a three-way handshake, and three-way handshake needs three packets for setup and for release respectively, right? It means here it requires three packets, and here also it requires three packets, so 3 becomes 6. And that's why even if sender want to send a single packet, then it requires a minimum of the three packets. So 1 2 3 4 5 6 7. require the 7 packets. Okay, so in order to avoid these unnecessary packets, then transaction oriented TCP is introduced. In transaction oriented TCP, TCP means transaction oriented TCP, and this TCP describes that version of TCP which avoids the overhead. Which overhead? The number of packets overhead. If you want to send a single packet, then it requires minimum 7 packets. So this is one of the overhead, and transaction oriented TCP removes this overhead. How it removes this? It is like this one. In transaction oriented TCP, connection setup, data transfer and connection release can be combined in a single packet, and thus it requires only 2 or 3 packets in order to send the single packet. Okay, then advantages of the transaction oriented TCP: reduction in the connection setup and release overhead. Right, so in transaction oriented TCP, connection setup, transfer and release packets are combined with the user data packets. That's why clearly it decrease the overhead which is required for connection setup and release process. Then disadvantages: the transaction oriented TCP requires the changes in mobile node as well as the correspondent node in order to work properly, and this particular solution no longer hides the mobility. It means there is no abstraction of the mobility in case of the transaction oriented TCP. Means any transmission error that occurs into the wireless part of the network, that can be propagated in the wired part of the network, right? Okay, and then this approach also exhibit the several security problems. So this transaction oriented TCP has some security problems that should be avoided for the proper functioning, right? So this was about transaction oriented TCP, and this was the last enhancement to the TCP protocol. Now here is the reflection point. So till now we have covered lot of things regarding the classical TCP improvements or traditional TCP and so on. So for this reflection point, the question is compare various TCP improvement approaches. It means you have to compare here, or you have to list out the differences between various improvement approaches. Improvement of approaches in the sense ITCP, MTCP, snooping TCP, or fast retransmit, fast recovery, or selective retransmission. Whatever we have seen till now under the classical TCP improvements, you have to make comparison of all these approaches. So take a notebook and list out all the differences. Before that, pause the video for some time. Okay, welcome back. We will see what are the differences between various TCP improvement approaches. Right. So these are the approaches, mechanism, advantages and disadvantages. So first approach is the indirect TCP. In indirect TCP, what mechanism is used? It means indirect TCP splits the connection into 2 connections. It splits TCP connection into 2 connections. It means one part is wired connection and another part is the wireless connection. In a wired part, traditional TCP protocol is used, whereas in wireless part, modified TCP is used, or enhanced TCP protocol is used. So indirect TCP have an advantage of isolation of the wired link, and it is simple as compared to the other enhancements. Disadvantage is that loss of TCP semantics, higher latency at handover, and security problems. So what is mean by loss of TCP semantics? Because here the foreign agent that acts as a proxy for mobile node and the correspondent node, and if that proxy is crashed, in that case there is no reliable delivery of the packets from correspondent node to the mobile node and vice versa. That's why this particular technique have a loss of the TCP semantics. Similarly, higher latency at the handover. It means if the mobile node has switched from old FA to new foreign agent, then the time required to hand over the old data to the new foreign agent is the large one in this particular case, and again it has some security problems. The next approach is snooping TCP. So snooping TCP snoops or observes the data in acknowledgement to and from the mobile node and correspondent node and vice versa. In addition to that, it performs the local retransmissions in case of the packet loss. So advantages of snooping TCP are: it is transparent for end-to-end connection. It means it retains the end-to-end mechanism of the TCP, and medium access control or MAC integration is possible in snooping TCP. And drawback of the snooping TCP are insufficient isolation of the wireless link, and again it has some security problems. Okay, so snooping TCP does not isolate the wired and wireless link properly. That's why some errors that occur into the wired network or wireless network that are propagated into the wired network and vice versa. The next approach is MTCP or mobile TCP. In mobile TCP, it splits the TCP connection into two parts, again wireless and wired part, and the mobile TCP chokes the sender by setting its window size to the 0, which prevents the sender for retransmission of the packets in the case when the mobile node is disconnected from the network. Okay, then advantage of MTCP is it maintains end-to-end semantics, handles long-term and frequent disconnections. It has drawbacks. Again, it has a bad isolation of the wireless link. Then it means it does not segregate or separate the wired part and wireless part of the network. Then it has a processing overhead due to the bandwidth management. It means in this MTCP, the supervisory host doesn't perform any packet buffering or any acknowledgement snooping. That's why this MTCP requires some additional hardware that is called as the bandwidth manager, and hence the processing overhead is increased in the MTCP. Again, it has some security problems as well. Then next approach is fast retransmit or fast recovery. In this mechanism is particularly used to avoid the slow start after handover has occurred. It means when mobile node switches from one network to another network, in that case there will be some packet loss, and that due to that packet loss the traditional TCP may initiate slow start, and in order to avoid that slow start, fast retransmit and fast recovery technique is used. Advantage means it is simple and efficient, and it has a drawback that is of mixed layers and it is not transparent. Then transmission or timeout freezing. Okay, in this particular approach, whenever there is a too long disconnection of the mobile node from the network, in that case TCP is freezed until the mobile node has again regains the connectivity. Its advantage is it is independent of the content. It means this particular technique doesn't need any acknowledgements or other type of the mechanisms, old TCP mechanisms, and it works for the longer interruptions. Means if there are the longer disconnections, then it is well suited. Then this technique is well suitable for such a problems. Its drawback are, in order to implement this particular mechanism, the changes in TCP on both sides, means mobile node as well as correspondent node are required. And another drawback is this technique is totally dependent on the MAC layer or data link layer. Then next is the selective retransmission. In this technique, retransmits only the lost data. Okay, so there is no need to transmit all the packets from starting up to the lost packet. That's why in selective retransmission technique, only that packet which is lost, that is retransmitted. And advantage is it is very efficient because retransmissions are very less in the case. And disadvantage is it is slightly more complex on receiver side, and more buffer is also needed at the receiver end. Then last one is the transaction oriented TCP. In this technique combines the connection setup, connection release, and the user data packet into the single packet, and that's why it requires less number of packets. Hence it is very efficient for the certain applications. And disadvantage is that changes in the TCP on both sides are required. It is not so transparent, and again it has some security problems. So these were the comparison between various mechanisms of the TCP, classical TCP improvements. Okay, now this is last point in this unit, that is performance enhancing proxies. So proxies are nothing but these are the host or computers that reside between the two entities, and main task or main purpose of the proxies is to hide the internal details of the either side. So performance enhancing proxies are intended to mitigate the link related degradation. It means performance enhancing proxies are required in order to decrease the degradation that occurs due to the links. The proxies can be placed in any layer in the communication system. For example, at transport layer we can have proxies, and proxies at the transport layers are used for the local retransmissions or acknowledgement, which are used in case of the say snooping TCP. Then proxies at application layers are used for the content filtering, compression, and the picture downscaling. For example, internet or web gateways. In the internet and web gateways, the proxies are implemented on the application layer location. Then next example of the application layer proxies are the web services gateways. But big problem of the performance enhancing proxies are it breaks the end-to-end semantics. It means it disables the end-to-end use of the IP security. Okay, so for any application, one has to choose between the performance enhancing proxies and the IP, and using the IP security. So this is the problem of the performance enhancing proxies. Okay, thank you. With this topic, the unit mobile network layer, not mobile network layer, mobile transport layer is completed. Again, same instructions are there. In order to protect yourself from the coronavirus, follow these precautions, stay at home and stay secure. Thank you for watching this video lecture.